Hello everyone, wishing you all a very good morning. I hope all of you are doing fine, safe, healthy, happy. As always, good morning Deepak, Vaini, good morning. All are looking so good today. Teja, good morning. Where were you beta? Shruti, good morning. Shruti, are you new in the class? I'm fine, see, fine. I'm always fine. Swati, good morning. How are you beta? All well? I see. Good morning Goli. I see so many of you joining and then so many of you getting disconnected. Something wrong with the network or what? Anyways, good morning, Satvika. Well, it seems that everyone knows where to. Yes, Shruti. Okay, welcome to the class. I hope you enjoy the class, Shruti. Sainath, good morning. And for Shruti, just for Shruti, I think all of us know what to do in the class. Keep your mobile cameras off. Sit in a place where you get good network so that there is no jig jig jig. Jig 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 means what's called buffering. And if you have to send any message, as you are doing right now, send it on my ID. Ask good morning TNK 3010. Put your name in front of your roll numbers. That would be better so that I can recognize you. If there are numbers I don't recognize whether you were there in the class or not. For example, I recognize Shruti that she was new just because I call everyone by your names. Satvika, I'm fine. I'm always fine. Whenever I'm not well, I let you know that I'm not good. Okay, chalo. Enough pleasantries for the day. Let us start with our task. What was the last thing that we were doing in the last class? Can anyone remind me of that? What was the last thing that we did in yesterday's, I mean, day before yesterday's class? What we were doing? Anyone remembers it? Does anyone remember it? What we were doing in the last class? Give me a quick recap. String had mass. So I think we were dealing with Vahini. Yes, we were doing questions, but I was talking about, I was asking which specific question were we doing? And Hanak has already given me the answer that we were doing a question where the string had mass. Do we recollect all of us that we were doing that question? Yes or no? Yes, Deepak recollects it. So if Deepak says yes, I think that should be the case. Vahini also remembers it. So what we'll do now is we'll also do one more question here. Uh, what was the important point that we discovered when we saw that the string had mass? What was the one basic point that we understood when we had this string with mass? When we had this string with mass, what changed? Did anything change in that string when the string had mass? Who will tell me that? What changed in that string when the string had mass? What was the previous case when the string did not have any mass? What is the new case where the string had mass? What changed? Anyone? Nothing changed? Tension in the string changed. Yes. Tension in the string changed. At one end, the tension was different. At the other end, the tension was different. As we had already seen in previous classes, that if the string has mass, tension will not remain same. We have seen at one end the tension was zero. In our case, not zero. At one end, the force was different, and the other end tension was different. Now we'll try to do one more question of the same kind where the string had mass. Now, instead of this being called as a string, we may refer to it as something else, something like a rod. It could be a rod, it could be anything that has mass and also has some length. Rope, yes. So, this is the question taken from your notes. Example number 12. Example number 12, and this is a very good question here. It comes many a times in different exams, including JEE, need everywhere this type of question comes. So we'll discuss this. Now, what do we see here is we have a rod of length L. As you can see, this mota thing, this thick thing is a rod of length L. Mass is not given. You can assume that the mass is M. At the end of the question, when we solve it, mass does not matter because mass gets cancelled. So horizontal force, as you can see here, a horizontal force F is applied on a uniform rod of length L and mass M, which is kept on a frictionless surface. Now this surface is not shown in the diagram because we don't need it. You can draw the surface if you want to. So if you can draw, this is the surface. Find the tension in the rod. Sometimes it may not be known as tension, it may be known as force in the rod. Force in the rod or tension in the rod, whatever they say, which means the same thing, at a distance x from the end where the force is applied. So here, if I call this end as end A, here we call this end as end B. End A is the end where this force is applied. Force is F. End B is the end where no force is applied. We can call it as the free end. Do we understand this? Do we understand this? That this end B will be known as the free end where we don't see any force being applied. The question is, this rod, this could be a rope with mass or string with a mass or wire with a mass, has a mass, a force F is applied. What is the force in the rod or tension in the rod or tension in the string or tension in the wire at a distance x from the end where this force is applied? Think about the question. See how it can be done. Now, can anyone tell me, just by looking at the diagram, what will be the force or tension at the end B? At the free end, what will be the force or tension? Can anyone tell me? Just by common sense, common knowledge. Physics is all about common sense and common knowledge. Can anyone tell me what will be the force or tension at point B? Are we all trying the question? Can all of you raise hands who are trying the question? How many of you are trying the question? Only 4 people are trying the question. What about the others? Some roll numbers. Tarun, I think Tarun is new. Shashank, then some numbers. I don't recognize numbers. Veronica, Yashwant, then some more numbers. More numbers. Vijay, Shruti, she is new in the class. Siddharth, Satvika, Sai, Yashwant, Padmakar, Dinesh, Praveen, Goli, Triveni, Likita. Likita, where are you? You were missing for the class for the past some days. I hope you are okay. Shashank, Charita, Venu, Rahul. Rahul also looks new. He comes in the class sometimes. I got some responses. Let me see what answers you are getting. Sir, I think same force. Not exactly better. Because if it is the same force, the question would be if there is the same force on point B, there would be same force everywhere at all points. And then the answer is at distance x, it is also F. So that is not correct. Same force is not the correct answer. Think about it. Don't worry. Till then, I'll give you a minute. Till then, I will do my thing. I hope all you are trying this question. Always remember one thing, that the answer is not important. Answer is the least important thing that I am concerned about. What I am more concerned about, is whether you are trying the question or not. If you are not trying the question, then that is a problem. If you are not trying the question, then that is a problem. If you are trying the question, it's not a problem. You might get the answer, you might not get the answer, doesn't matter. Getting the answer is the least of my concerns right now. Okay. How many of you are trying the question? Well, good. Anyone got anything that looks like an answer? Any thoughts anyone would like to share? Anything that anyone would like to point out? Sir, I think this, sir, I think that. Hanak says no force. Yes, Hanak, you are correct. There is no force on the other end of the rod. You are absolutely correct on that. See, Hanak, I guess that you are improving day by day, and I'm very happy for you that you are improving. Just keep your hard work on, and I'm sure that you can do well. See, anyone who works hard for 2 years, it's easy to score 180 to 200 marks in JEE Main. If you get 180 to 200 marks, I can assure you, you can get even Warangal. I think that's the IIT that you are, that's the NIT that's there in Telangana. I am sure that you can get Warangal, at least Warangal. But you must work hard. That's it. Anyone else with an answer? If no one is there with an answer, then I must proceed with my thought process. Yes, beta, rod is only one project, one object, yes, but there is, whenever you apply force on one end, the same force is not acting at all the points. The force is different, and that is what we have to understand. Up till now, what we were doing was, we were considering everything as a point object. Car is a point object. We apply F on the car, we assume that it is a point and the same F applies everywhere, but that does not happen in reality. Because in reality, this is a solid body. When you apply force on one end, these particles inside this rod, they start applying forces on each other, which is not equal to F. Because if everywhere force is F, nothing happens then. Okay. Let us first start. Draw a sketch. I've drawn the sketch. Draw the free body diagram. I can always draw this weight mg. It will not make any purpose here. Weight is mg, n is the normal reaction, and from this you can get the value of n. The normal reaction from ground will be equal to mg. That is not the concern right now. Right now the concern is how to get the tension at a distance x from the end of the rod. Now please listen to me carefully. Eyes on the board, because you will have this board. You may not write notes. If you can't write, I would be very happy if you write it, because that is one thing that will help you a lot. Now, I'm applying this force on this rod. Now this rod is one body, so it will have to move as one body. In which direction will it move? It's simple. It will move in the forward direction, right direction, like this, along the red arrow. And it will obviously move as one body. So the acceleration of this body will be A. Do we agree on this? Yes or no? That this entire body will move as one. Acceleration is 8. Now, I think this first diagram is okay. Now, from this first diagram, I can also write the equation along y-axis, n is equal to mg. I don't need that. N is equal to mg. What is the equation along x-axis? As you can see, there is one force F acting like this, and the body is accelerating like this. Can we write any equation along the x-axis for this body? Who will tell me the equation? Along the x-axis, what is the equation? Along the x-axis, what is the equation for this? What is the equation? Anyone? The equation is simply F is equal to ma. Yes or no? Where F stands for the force acting on this body, m is the mass of the entire rod, and a is the acceleration of the rod. Do we understand this? F is equal to ma, blue one. There's no force on the other end. F is equal to ma. So far, so good. Okay. Great. From here, I can get the value of a, actually. The acceleration of the body is F by m. This is what I've derived from this side. Let me make a column here so that I don't get confused. Okay, now let us move on to the right hand side. Now what I have drawn on the right hand side is the FBD, free body diagram of what? Of the length x, only the length x, not the entire body, but the body of length x. Now when I draw the free body diagram of this body, I'm not drawing the forces on the up down side. I can also draw the force on the up down side. Okay. Now the first question is, if I had to draw the force on the up down side, what is the mass of this body? What is the mass of this portion? That is the first thing that we must understand. What is the mass of this portion? Who will tell me what is the mass of this portion? What is the mass of this portion? How will you get it? It's very simple. M by 2. No, Yashwant, that is not correct. M by 2 is not correct. Imagine you have this entire body, which I am now coloring it. You have this entire body, the pink one. The mass of this entire pink body, is M. The length of this pink body is L. Mass is M, length is L. Now I have this yellow body. Yellow body is not a different body, but yellow body is a part of this bigger body. Its length is X. Its length is X. Part of the same body, length is X. The body is uniform. What will be the mass of this part? What will be the mass of this part? How will I get it? Total mass is M. So I divide this M by L. Now this term M by L becomes mass per unit length. This becomes mass divided by length. It is something like this. If I have a rod or this pen, let us say, yes, Santosh, you are correct. Let us say the mass of this pen is 5 kgs and the length of this pen is 5 meters. Mass of this pen is 5 kgs. Length of this pen is 5 meters. If I cut 1 meter of this pen, what will be the length? What will be the mass of that 1 meter? You will say, sir, 5 meter. The length of 5 meter is the mass of 5 meter is 5 kg. So the mass of 1 meter is 1 kg. You divided kg by length. Mass per unit length is M by L. So the mass of a unit length of this pink or pinkish object is M by L. So what will be the mass of X length? And the answer now becomes simple, that the mass of this X length will be M by L times X. Do we all agree on this? Do we all agree on this? The mass of this portion X will be M by L into X. Do we agree on this? Then I have reasoned that we agree on this, sir. Only 7 people agree. Some roll numbers. Tarun, I think he is new. Shashank, some roll numbers again, I don't recognize them. Vijay, Suren, Siddharth, Satvika, Sai, Reddy, Pashmagan. Okay, everyone understands. Okay, got it. Let me know. So once we have understood this, then the part becomes simple. So here it becomes, the weight goes down. The weight is M by L X multiplied by G. The normal reaction comes up. Let me call this as N1. Now I can write the equation for this block. N1 is equal to this thing. I don't need this because I don't worry about the normal reaction. Now, remember, there is one more portion of this length, which is L minus X. Now this L minus X is trying to push this block here. So there is one more force acting on this from here, T. Now this is that T which we are supposed to find the value of. The question was, find the tension in the rod at a distance X. This is that tension that we are supposed to find out. So what is happening when I apply force on the rod? The particles here are pushing the particles here. This particle are pushing these particles in this direction. So these particles are pushing these particles in this direction. Similarly, I can assume that X length is pushing the remaining length in this direction, or L minus X length is pushing X length in this direction, and that is T. You will understand this. T is the force applied by the remaining part on the part X. Okay, done. Now, we must remember that this entire body is moving ahead with an acceleration A. So I write this is moving ahead with an acceleration A. Now, the force along y-axis will equate. So N1 becomes equal to M by Lx into G. No one is worried about that. What we are worried about is the blue, the x-axis wala equation. F is acting here along this. Acceleration is also along this. But there is T, which is here. What equation do I get along x-axis for this body? What equation do I get for this body along x-axis? F is here. F. T, the force of L minus X is on this side. F minus T is equal to mass of this section. Now this section has a mass M by L times X into A. That becomes the equation for the second half. Do we understand this? Can I have raised hand that we understand this? I'm lowering all hands. Do we understand how I made this equation? The only thing that we have to understand here is what is the length, what is the mass of this part, M by L into X. And we just made the equation. We just have to understand that this part is pushing this part. So this part is going to push this part. That's it. These are the two things that we have to understand, and they are pretty obvious. Now, from equation number 1, I can put the value of, from equation number 1, I can put the value of A in equation number 2. And now you can get the value of T. I'll give you 2 minutes. If I do everything, you will not be able to understand the problem. So I'll not do the last part, which is solving the equation part, because you will have to get some confidence that we can get the answer. If I do everything, unless and until you do a question with your own hands, you never understand that question. Any question in maths or physics, if you just read it, you never understood it. So now tell me, what is the value of T after solving these two equations, and let me see who gets me the value of T first. What is T equal to? A you know, the other equation you know, F you know, X you know, the only unknown is T. Get me the value of T. What is the value of T? What is the value of T? Anyone? You have to put the value of A from equation number 1 into equation number 2, and you are done. Waiting for your answers. No one? I have to get the value of t. I have to get the value of t. I have to get the value of t. And the answer is this. T is equal to f into 1 minus x by L. And that is the tension in the rod as a function of x. That is the answer that you will get. F t is equal to f into 1 minus x by L. Varun, there is a small mistake that you have made. You have written f into L by L. F into L by L is f into 1. So you have to write it like this. F into 1 minus x by L. Do we all understand this? Can I have some raised hands that we understand this? Only 2 people have understood this. 14 people? No, it should be more than 20, 25. Let me wake everyone up, whosoever is sleeping. Okay. Varun, some roll numbers. Tarun, some roll numbers. Yashwant, Siddharth, Satvika, Sai, Satvika, where are you? Reddy, Padmakant, Dinesh, Praveen, Pranay, Kevin, Karthik, Shashank, Charita, Venu, everyone. Okay, great. Now remember one more advice. This is not the only way that you can do this question. How did I do this question, Varun? On the left hand side, I made the diagram of the entire body. F is here, acceleration is here, F is equal to ma. On the right hand side, I made the equation for the part x. The length of this part x is m by L into x. F is here, t is here, F minus t is equal to m by x into L, m by L into x into a. I put the value of a from equation number 1 and I get the value of t. Now, this is not the only way of doing it. Remember, in this particular chapter, there can be more than one way, maybe 3, 4, 5 ways of doing the same question. Varun, do you understand this now? There may be more than one way of doing this question. Now, instead of making the equation of this block, which was the length x, I could have made the equation of the block L minus x. I could have made the equation of the block L minus x and still solve that question. So I'll just show it to you and probably the answer would have come more quickly. Now, see, on the right hand side, I have made the equation of the block x. Down below, that is here, I will now make the equation for the block L minus x. L minus x is the remaining portion. L minus x is the remaining portion. Now, what will be the mass of this portion? Who will tell me what will be the mass of this portion? What will be the mass of this portion? The mass of this portion, m dash, will be equal to m divided by L, mass per unit length, multiplied by L minus x. Do we all agree on this? Yes or no? The mass of this portion will be m by L multiplied by L minus x. Yes or no? Now, if I have to draw the forces, I can call this reaction as N2 and I can call this force as m by L. I don't need this equation, but I always draw this equation because we will be needing it very soon. We'll be needing it very soon in all the questions. As soon as friction comes, we will be needing this equation. Even don't we need it, we will be writing it. We'll be needing it, we'll be writing it. So N2 becomes equal to, the green equation is N2 equals to this one, Everyone knows this. Now, remember what? In this T was the force applied by L minus X into X, like this. So what is the force applied by this X into L minus X? It will be like this. How much will be the value? How much will be the value? Yes, beta, it would be equal to T. So I just apply the force T like this. Do we all agree on this? T is the force applied by this body on this, like this. I could have written T here also, beta. Doesn't matter. It's same. The direction is same, so I could have written it anywhere. So instead of writing it there, because it might confuse you on this side, but how is the force coming on this side? Therefore, I'm writing it on this side. Do we understand this? Why I written it on this side? Because so that it does not confuse you. T. Now remember, this entire thing is moving with an acceleration A. What is the equation for this block? N2 is equal to what? Weight. Done. No need here. What will be the equation for this block along x-axis? It's very simple. It will be equal to T is equal to M, mass of this block, M by L into L minus X into A. Now A, yes, bacha. A already we know. A is F by M. Now you solve this. We'll get the value of, this is easier to solve than the previous one probably. You'll get the value of T. And what value of T you will get? You will again end up here. See for yourself. You'll again end up there. So in physics, in this particular chapter, may not be in the chapters which are coming ahead. You may have more than one way of solving the question. Now it depends on your choice, your liking, how you solve it. If you refer books, if you have books, you will find the same question in different books. It's very common. Same questions are revolving everywhere in the universe. Same question will come in your exam. That is why I'm so confident that whatever I do in the paper, whatever I do in the class here will come in your paper, because the questions are same. Same questions are wandering in the universe. You just pick one and put it. The way that same question is solved in different books would be different. Don't get confused. Don't get yourself influenced by one book. Okay, this is the way I should solve it. I should not think in the other way. No, there could be another way to solve that question. And that is why I ask you to work hard. If you work hard, you will find your own ways of doing the question. Did you understand the second way of doing it? In the first way, what did I do? I made the equation of the entire rod. Then I made the equation of x wala part. In the second way, what did I do? I made the equation of the entire part. And I then made the equation of L minus x wala part. I could have tried the third way. What would be the third way? I first make the equation of x part, and I then make the equation of L minus x part. You can also try it. That again, you will get the same answer. There is still one more way of doing it. And that is as simple as it gets. Doesn't matter if you understand one way or the other way. There's still one more way of doing it that is as simple as it gets. This is ground. This is the rod. This is the length L. I apply a force here F. The force here is 0. One end force is 0. Another end force is F. What will be the force at this point? What will be the force at this point? That is what you need to find out. Now we'll assume that the force is varying uniformly. Here the force is F. Here the force is 0. Here the force is F. Here the force is 0. So force is varying uniformly. What is the variation per unit length? The variation per unit length is F by L. So how much will the force vary for a distance x? The force will vary F by L into x. Here the force is F. At this point, it has decreased. It has decreased by this much amount. So what is the force at this point? Total force F minus the amount it has reduced, F by L into x, and that is your answer straight away. What is the moral of the story? The moral of the story is one question can be done in a different number of ways. One book will show you this, one book will show you this, one book will show you this. I have showed you 3 of those ways. I can do this in a different way also. The thing is, you'll have to understand it. And how do you understand it? By doing it with your own hands. Did you get my point? Force here is F, force here is 0. It goes from F to 0. So what is the change in force per unit length? Same as mass per unit length. Force per unit length, F by L. How much will it change for a length x? F by L into x. Here it is F. Here it has changed by F by L into x. So what is the force here? F minus F by L into x. There are many ways to do the same question. Have faith that you have read it. If you have read it, you can do it. Are you confident of doing it now? How many people think that we are confident now that we can do this? Please raise your hands. Only 2 people? What about the others? Only 5? What about the others? Only 8? What about the others? Only 11? What about the others? Well, good. Now, just to check whether you have understood the concept or not. Here is a question that will check, and I would be very glad if someone gives me the answer straight away. If someone gives me the answer straight away, and I will hide the answer, therefore. Oh, I can't hide it. Okay, let me not hide it. Let me, chalo. I trust that you will not see the answer. This is the question now. Slightly changed. Slightly changed. 2 forces, F1 and F2. F2 is greater than F1. Are applied at the free ends of a uniform rod kept on a frictionless surface. Find the tension in the rod at a distance x from the end A. Let's see who gives me the answer for this one. I'm not going to solve the question, I'll just write the answer. If you have understood the previous question, this is the one that you should be able to do it in a flash. Let's see who can do this. A minute, 2 minutes. F2 is applied on this end. F1 is applied on this end. F2 is more than F1. What is the force at a distance x? That is the question. Anyone there? You can answer. Anyone who thinks that he got the answer? Let me know. No one got the answer? Anyone got the answer? So the answer is pretty simple. At this end, the force is F2. At this end, the force is F1. How much it has changed? It has changed by F2 minus F1. What is the change per unit length? It is divided by L. How much will it change for a distance x? It is multiplied by x. So what will be the force at this point? F2 is the force at this end. So F2 minus F1 by L into x. That will be the force at the other end. At the end at a distance x from the end A. Do we understand this? This part is the change in force. This part is the force at the one end. And here is our answer. F2 minus F1 divided by L into X. The only difference in this question was, in the question, our question, F2 was given as F and F1 was given as 0. If you put F2 as F and F1 as 0, you will get the previous answer that we had discussed. Do we understand this? Can I have raised hand that we understand this, sir? Lot of people seem to have understood this. Now I'll have all lowered hands. How many of you got the answer on their own? How many of you got the answer on their own? How many of you got the answers on their own? No one? Did anyone get the answer? By your own efforts? No one got the answer by your own efforts? Okay. Even that is not a problem. As soon as you grow up, the more you work hard, the more you practice, you will be getting all these answers on your own. And I am pretty sure about that. That is the day I'll tell you that, once you start getting answers on your own and one day you will start getting them, that is the day you will be prepared for your exams. Now let us move on to another question. Now, as we go ahead in life, first we get easier things, then we start to get things which may not look so easy. So, are we ready to do things that are not so easy? This is the diagram now. Obviously, the block is frictionless. I mean, the surface is frictionless. We are supposed to find out the acceleration of the blocks, the tension in the string, and the normal reaction. How many tensions, how many strings you see here? I see two strings. This is string number 1 and this is probably string number 2. Yes or no? Yes. Okay. How many normal reactions you will have? You will have two normal reactions, right? One for block 1, another for block 2, M1 and M2. Now, where is this system going to move? Where is this system? How is this system going to move? Anyone have any idea? Anyone has any idea how is this system going to move? Where will this system move? This is our right side. Okay, so this will move here and this block will also move here on this side. Now, the next question is M1 towards right. M1 can only move towards right. M2 can also move towards right. There is no other way there can be any other motion. Now, can you tell me if I move this block with the acceleration A, what will be the acceleration of block M1? Will it be A or will it be different? If I move M2 with an acceleration A, what will be the acceleration on the block M1? Anak says A, Goli says A. Why do you think that it is A? Give me a reason. It can be A, but how you can be so confident that it is A? Satvika also says A. Moving in the same direction. If two bodies move in the same direction, does that mean that all are moving with the same acceleration? No, no. I think A by 2. It's not A by 2 actually. It's 2 times A. Anyways, they will not move with the same acceleration. Up till now, when just 2A, Vaini is guessing now. How did you get 2A? That is the question. You must understand here that these two blocks are not attached by the same string. They're attached by two different strings. I've clearly shown those two different strings. So if they are not attached by the same string, you don't have the same magnitude of acceleration. So here I will have to call one as A2 and the other one as A1. I'll have to call one as A2 and the other one as A1. Now the question is, find the values of all these things. What are the things that you have to find out? There are two accelerations. Yes, wall doesn't move better. Wall cannot move. That is why. So now let us try to solve this question. Let us see how we can solve this question. I'll give you 2 minutes. Apply your way. I know that you know the way of solving this question. And let us see what equations we end up with. 2 minutes. Vine is giving me equations. T1 is equal to M1A. T2 is equal to M2A. Vine is making her life more difficult, and it actually is. Anak is having his own problems. He's saying, sir, string is attached to the wall. How will the block move? It will move. String was always attached to something. When the pulley was attached, it was attached to the wall only. Pulley was not moving there. Here pulley is moving, and that is the problem. Up till now, whatever questions we did, pulley was stationary. Here, this pulley is moving. So this is one thing that has changed. Pulley is moving. Pulley moves. Anak, am I clear? Pulley moves. Up till now, pulley was not moving. Now the pulley is moving. Okay. Let me not take more time, and let me start my lecture. First step, draw a sketch. Sketch is there. Second step, isolate the bodies. Bodies are very far away from each other. Third step, draw the free body diagram. Let us start. And as always, I always start with tension. So let me call the tension as T. T. Remember, tension in the same string remains same. T. String 1 is done. T and T on this side. So what will be the tension on this side? T and T here. Remember, pulley is massless. 2T. Yes, 2T. 2T is this side. So 2T will be the tension on this block. Like this. Now let us move on to block number 1. The all other forces are M1G and normal reaction N1. This becomes the free body diagram of M1. Now let us first solve this question so that we don't get confused. N1 is upwards, M1G is downwards. Is the block going to move like this? No, it will not move like this, right? It will not move along y-axis. So what is the equation we have along y-axis? Can anyone help me? What is the equation along y-axis? N1 equal to M1G. Do we agree on this? Yes, so we all agree on this. No problems with this equation. M1 is equal to N1 is equal to M1G. So far, so good. Yes, Ashwin, that is correct. Now let us think about the equation on the x-axis for the block 1, the blue one. T is आगे, A1 is आगे, block का mass is M1. Let us now write the equation along y-axis for this gentleman. Sorry, not y-axis, x-axis for this gentleman. Let me make a bundle here. Okay. Let me make another bundle here. Okay. So that I don't get confused. I get confused. Okay. X-axis. What is the equation along x-axis for this one? Who will tell me this equation? T is आगे, A1 is आगे. The equation becomes T1 is equal to M1 A1. Can I have raised hands that we all agree on this? Do we all agree on this? Any doubts anyone has on this one? So far, so good. Everything is similar, as you can see better. Nothing has changed. Nothing ever changes. You must have that confidence in yourself that nothing ever changes. Now let us move on to block number 2. M2G comes down, N2 goes up. Let me make this pink equation. It does not move like this, dung, 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 dung. So I have the equation along y-axis for this block. What is the equation along y-axis for this block? N2 equates M2G. That becomes my equation along y-axis. So far, so good? Or are we having trouble? So far, so good? Yes or no? So far, so good? Can I have some raised hand that we understand this, sir? I'm not getting participation. No good. I need participation. So far, so good? Now let us see what do we have along x-axis. F is here. 2t is here. And A2 is here. I hope all of us see this. Now, can anyone tell me what is the equation along x-axis for this block? X-axis for this block. F is this side, 2t is this side, and A2 is this side. Yes, Yashwant, you have got the equation F minus, oops, I made it wrong. F minus 2t equates M2 A2. That is the equation that I was looking for. The light green one. F minus 2t is M2 into A2. We have got the equations now. Well done, everyone. Appreciate your efforts. Now, the only thing that's remaining is solving this equation. In fact, do we need to solve them? See, from this first one, we already have the value of N1. So, N1 is M1G. Don't need to solve it. From this second equation, I have the value of N2. N2 is M2G. So, two equations done. Y-axis, give me the values of N1 and 2. Done. Now let us look at the x-axis equation. I have written here T1, it should be T, so I must correct it. This must be T, not T1, it's T. Let me now see how many equations I have. This is equation number 1 along x-axis, and this is equation number 2 also along x-axis. Equation number 1 is for block 1, equation number 2 is for block 2. Let me count the number of unknowns that I have. T is unknown number 1. A1 is unknown number 2. Two unknowns. F is known. T is unknown number 1. A2 is unknown number 3. Oh no. Oh no. 3 unknowns. 3 unknowns. 3 unknowns, but 2 equations. Does it remind of does it remind us of something that we already encountered in one of the questions that I gave you? Number of questions, number of equations were less, but number of variables are more, so you need one more equation. From where do we get that equation? We get that equation from something known as constraint relation. Now, what is this constraint relation? I'll give you a small task. Find out. Search on the net. Search on Google. Google it. Yahoo it. Whatever. Try to find out what is this constraint relation. There are different ways of finding out this constraint. I'll tell you my way. And my way is always the simplest way. To find it out, in the next class, we'll try to do the impossible here. We only have 2 equations, but we have 3 variables. We have to manufacture, produce, create, invent. one more equation which does not look possible here because we already made equation along x and y, z axis, there is no force, so there is no equation. It looks impossible now. We'll make this impossible possible in the next class. Yes, it only works when strings are inextensible. A1 is 2 times A2. That is correct, Santosh. We'll try to find out how we are good. Sir, we can't use T1 is equal to T3. There is no T3, there is no T1, only T and 2T. We'll try to understand how will we get this equation in the next class. Do not miss the next class. If you miss the next class, you will not understand anything from the class thereafter. So don't miss the next class, and we'll have a good time in the next class. See you then. See you then in the next class. Till then, goodbye. Take care. Stay healthy. Stay happy. Bye bye.